So let's look at the second part. In this part, you are going to understand two kinds of permutation, the definition and the formula. But I'm not going to let you or force you to remember the definition and the formula of permutation. Instead, I would like you to totally understand how it is coming from. And then you are going to apply the formula or reasoning through strategy to solve some basic permutation problems. So let's go back to the example we talked about before. In that example, there are totally 6 students from your class, and they are going to sit in a line and take a group picture together. The question is, in how many ways can they be arranged in a straight line? So the solution is 6 times 5 times 4 all the way down to 1, that equals to 720. But now let's think about another case. So what if there are only 3 chairs, but you have 6 people want to take a picture together, which means only 3 out of 6 can sit down for each photo taken. So in how many ways can they be arranged in this kind of situation? I suggest you to pause the video for about half a minute and think it through. Okay, so I suppose you already think it through. So now let's look at this problem, and I will help you to solve this problem using the metacognition strategy we introduced before. So now let's recall. Do you still remember what is the first step of the metacognition strategy? Yes, the first step is to identify the problem type. Identify the problem type. So now we have 6 people and we have 3 chairs. So it's kind of similar to the problem that we solved before, if we contrast them together. So the old problem is that we have 6 people and we have 6 chairs. We have 6 chairs. So in that problem, we use the multiplication principle there. Since this one, the new problem and the old problem, actually they are quite similar in structure, in a deeper structure, just instead of the superficial structure. So in the superficial structure, it seems the number of chairs varied, but actually in the deeper structure, there also is it is also the problem about the number of selection for different choices and how many choices are here. So I have to use the multiplication principle to multiply them all to find the total number of the selections. So now we are going to transform the new problem into some old problem we solved before. I guess the trigger of transformation is that the structure of the problem is similar to the previous one. So the trigger is the structure. And I'm just going to use the multiplication principle here again. So now we have 3 chairs, which means we have 3 choices. So for the first choice, we have 6 selection because here we have 6 people. So for the first one, we have 6 selections. And for the second one, we have 5 because the first one is already sitting in the first chair. So he or she cannot sit both in the first chair and the second chair. So for the second chair, we only have 5 selections. And for the third one, we have 4 selections. Okay, we can just stop here because there are only 3 chairs, so we have to multiply them all together. That is 120. So actually the difficulty level here for this problem is quite reduced compared to the problem we solved before, because we only stop here at 4 instead of all the way down to 1. And for the first step is the self-checking part and monitoring. So now let's think it through. So we have 6 people and we have 3 chairs, and we use the multiplication principle here to solve the problems. Did we address all the problem here? Yeah, I think so. I think we already answered the question that is from the problem. So we are ready to move to the 5th step, that is about the reflection. So after solving this problem, we already know that when we face this kind of problem, it doesn't really matter like how many chairs are here, whether the number of chairs is equal to the number of person. We can just apply the multiplication principle to reason through. So in the future, if we encounter this kind of problem, we can think, oh, I'm just going to use the multiplication principle to reason through. That is a strategy that can solve this kind of problems in the future. So okay, I know that. So in the future, if I encounter that kind of problem, I can solve that. I'm confident in that, right? If you're going to look at these 2 examples we just talked about, can you see any differences between these 2 questions? Yes, the difference between these 2 questions is that for the first problem, we have 6 chairs to sit. But for the second problem, we only have 3 chairs to sit. So that means we have to select 3 people to sit on the chairs out of 6 of them. So now we are going to give a name to this kind of problem, that is a permutation problem. So the definition of permutation is, a permutation is an ordered, let's put some emphasis here, an ordered arrangement of R objects chosen from N. So the N and R, they're not necessarily to be equal. For example, in the first example, we have R equals to 6 and N equals to 6. The N is the people here, and the R is the chair here. So for the second one, we have N equals 6 because we also have 6 people here, but the R only equals to 3 because we only have 3 chairs here. So you can see the R is not necessarily to be equal to the N. So the notation of the permutation is that P bracket N comma R bracket, and that represents the number of ordered arrangements of R objects chosen from N distinct objects where R is smaller or equal to N, and the repetition is not allowed. So now let's look at the calculation process of these 2 examples. So for the first one, we have the permutation with N equals to 6 and R equals to 6. So that is 6 times 5 times 4 times 3 times 2 times 1. That can be write in a simple way, that is 6 factorial. Just in case if you don't know what is factorial, that is a really easy operation. So if you have 6 factorial, that means 6 times 5 times 4 all the way down to 1. And if you have 3 factorials, for example, that should be 3 times 2 times 1, that equals to 6. And if you have 2 factorial, let's make it bigger. So if you have a 4 factorial, that should be 4 times 3 times 2 times 1, that equals to 24. So if you have n factorial, that should be n times n minus 1 times n minus 2 times all the way down to 1. So if you have a 0 factorial that just equals to 1, you have to remember this special case. So here we can write the 6 times 5 times 4 all the way down to 1 in a simple way, that is 6 factorial. So now let's look at the second one. So the second one, the permutation is we have n equals to 6. That's the same, but r equals to 3 because we only have 3 here. So that should be 6 times 5 times 4. Okay, if we are thinking about using the factorial notation to simplify the notation of this formula, what can we do here? So basically, the 6 times 5 times 4 is 6 times 5 times 4 times 3 times 2 times 1. That divided by 3 times 2 times 1. Look familiar, right? So here we have 6 factorial, and here we have 3 factorial. That is 6 factorial and 6 minus 3 factorial. So now we can draw the general formula of permutation. That should be, if we have P and R, that should be n factorial divided by n minus r factorial. So this one, if we have a permutation of total number here, so that should be, if we write in a general format, that should be 6 factorial divided by 6 minus 6 factorial. That is 6 factorial divided by 1, because we have a special case here that's 0 factorial equals to 1, so that still is 6 factorial. So now the general formula is confirmed to be P and R that equals to n factorial divided by n minus r factorial. So now we write down here, if the n objects are distinct and once the object is used, it cannot be repeated and the order is important, so we use the formula of P and R permutation of n objects taken R, that is n factorial divided by n minus r factorial. So now let's look at a new example. So here, a group of 7 people, they are going to wear the costume for Halloween, and there are 7 different costumes: the parrot, the princess, the vampire, the wolfman, the Superman, the Batman, and Mickey Mouse. So they are going to select any costume as long as no one is taking this one. So in how many ways can they wear the costume? I suggest you to pause the video for about half a minute to think it through, and then I will tell you how to solve this problem step by step. So okay, I suppose you already think it through. The first step of solving this problem is to know what is the problem type here. So here we have 7 people and we have 7 costumes. And if we contrast this new problem with the problem we solved before, you can see, oh, this one is pretty similar to the one we addressed before about 6 people taking a group picture together in a line. So that is super similar. So do we have to do any transformation for that? Probably no, because they're super similar. It's actually the same because they're in the same case and they will use the same way to solve the problem. So if we recall, how did we solve the problem of 6 people sitting down together, which is 6 chairs? So how did we address that? The first way is to use the multiplication principle to reason it through. So that should be 7 times 6 times 5 all the way down to 1. And the second way to do that, just remember we just introduced the permutation formula, so that should be the permutation of 7 people and 7 costumes, which means n equals to 7 and r equals to 7. So that should be 7 factorial according to the formula. So this and this are actually the same thing here. So we got the correct answer. And then we're going to do the self-check. So if we read it through all the conditions in the problems, they have 7 people and 7 costumes, and there's no other conditions here, so we can say, okay, we addressed all the problem in this question, so we can say we solved this problem. And for the reflection part, so if you think about the process we solve this problem, we first recall the process that we solved the previous problem. So in this way, we know exactly how to solve this type of problem. And in the future, we will solve this type of problem using the same strategy and in a faster process of solving that. So that is the really a good way to solve the problem. That is the advantage of make your mind organized, because in the future when you encounter the similar problem, you will come up with a way to solve it really quickly and immediately. That will save you time.